All right, so we got a packed classroom today full of one person, but we're going to be talking about databases. I would really recommend that you guys check out the GitHub repo for the Software Engineering Bootcamp. I wrote a really in-depth lesson with links to all this stuff, and I linked to a repo where I'm showing you some code. This is really good stuff to have and know. We're just going to jump into what's a database, why would we use what certain types of databases, how do we interact with them, and then we're going to set up our own and start writing to it. So right off the bat, let's take a look. There are primarily two types of databases if we're categorizing them at a broad level. We have relational and non-relational. We're going to be today doing relational. So relational, probably the biggest one is MySQL and Postgres are probably the big two. I like Postgres, it's open source. If it's good enough for Google, it's good enough for me. Lots of people use Postgres. There's a bunch of these. The amount of databases that are out there is insane. SQL just means server query language. We'll touch on that in a second. NoSQL doesn't mean no SQL, it means not only SQL. It's a bit misleading. Here's the primary difference. SQL databases are relational. Every object in the database has a relation to some other object. So for example, if you have a list of cars in your database and you have a list of owners, you'll have a one-to-many relationship where one user or one driver can own many cars. Likewise, there are many cars to one person. You can have a one-to-one relationship. For example, you can probably only be one student at one university at once. I'll show you a list, but on the NoSQL side, typically we have like a key value storage. So like JSON objects, where they have message, hello world, friends, and then an array, and it's just a JSON object. A lot of NoSQL is stored like that. MongoDB is really big. Firebase we talked about. DynamoDB, it's Amazon's MongoDB. Neo4j is really taking off. It's a graph database, so it's going to look really different. Something like Prometheus is a time series database. There's databases for all sorts of stuff. So schema. A schema is a collection of objects in your relational database. So the main thing that I would think of is a table, which we'll show you as we get into it. But a table, for example, we have a table users here. A user would have a user ID, a username, email, birth date, and a registration date. And our table of users in our database stores every single user that we have. Simple enough. When you say it like that, but they can get pretty complicated pretty quickly. There's also views. Virtual table happens when you join tables together in a certain way. Like, show me all the users who also have logged in the past 2 weeks, or show me all users who also attend class at George Washington University, or something like that. It creates a virtual table, and then we query that table. You can see this is some SQL that I wrote here. This is a nightmare. I hate SQL. I think everybody hates SQL. You don't?
I'm teaching SQL.
Okay, so someone here is teaching SQL. I'm going to teach you how to not do SQL and just use TypeScript. So here's some examples of our relationships. One-to-one, an employee manages a department. You don't manage multiple departments, one employee per department. That's a one-to-one. One-to-many, a publisher publishes many books. On the flip side, a book, there are many books per one publisher. So if we were looking at the relationship from book to publisher, that would be many to one. Many to one, so there are many books per one section in the library. And then many to many is a little bit trickier. Each course has many different students in it. Each student takes many different courses. And when you're doing algorithmic stuff, like in social networks, the top three, if you're working with, aren't that bad. But as soon as you're looking at who are my friends of my friends who also do this, it can get very complicated very quickly. Many can be tricky. So SQL, we're just going to skip right past SQL. So here's the goal for today's lesson. I want to show you guys how to put Postgres on your computers. Now you can put this on an Amazon server if you rent a server in the cloud. You can put it on an Amazon server, and everything we do today, if you do it on an Amazon server and set it up with a URL, you now have a website that works, that's accessing a database. You're on a Mac? No. Not a Mac. Great. I don't know how to do it with Windows off the top of my head. I wasn't going to walk everybody through installing it today. I was going to show you how to do it once it's already installed. I would recommend probably just checking out their docs and saying what the easiest way is to do for Windows. And I'm going to ignore the other ones. What you can do, have you ever heard of Docker, containerization, anything like that? It's sort of more not something that would be covered in a CS department. Essentially, it's like, and this is a super zoomed out level, it's like a virtual machine that runs Postgres for you. So you don't have to run Postgres. You have to run the virtual machine that runs Postgres. So it makes it really, really easy. If you downloaded Docker and then said, give me an image of Postgres, you could probably have that up and running within like 30 seconds. That is another way that you can look into doing it, but anyway, it's not a Docker lesson. For your shell, there's Postgres server query language, PSQL. It's going to open up a shell in your terminal, which I'll show you in 2 seconds, which is going to allow us to interact with our database. Now, when you first create or first install Postgres, you're going to have to create a username and password. I and everyone else would recommend just put Postgres for everything. It makes it easier. Of course, if you're doing this on the cloud, probably some better security would be in order. I will show you controllers, routes, and views once we get into the actual Express. But for now, Express essentially has 3 parts to it. Views is going to return the actual HTML. We're not using that. We're doing Express only for our backend. We're not serving static content out of Express. That's all going to be handled by React, so we don't have to worry about that at all. We also have controllers and routes. Well, routes we talked about yesterday, and that's basically app.get, app.post, app.delete. We have the actual route name, and then we have some logic that we want there. Return a response, return some data, etc. And then finally, controllers control what happened at our routes, and that's typically the business logic. So if we're doing something with our database where we want to insert a new user, delete a user, controllers would manage this for us. Let's take a look. So, here's my terminal. I just opened this up. So if I do PSQL, it's going to open a shell in my Postgres server query language shell, which allows me to interact directly with all the databases on my system. If I do list, I have a whole bunch of databases here. Almost all of these are for testing. When I actually move to prod, they're on another server somewhere. But my computer has each one of these databases on it. I can run all of them as needed. I can access them. I can query them directly from the shell. The only time that I personally would do that is if I either want to delete one of these guys or I need to do some manual operation to it. It's pretty rare. If you're like a database administrator, you'll be getting more into it, but devs normally won't have to. So what you would do is you would do, I think it's PSQL create DB. Okay. I believe this is an error with my system because I'm not running a Docker image right now. That's why I would recommend doing Docker. It's a little bit finicky to get it to play nice all the time. But if you see that connection to server on socket failed, it's probably a system error. Let me make sure that I can still actually connect to this. Yep, we're good. So let's take a look at our application. So this is going to be based on some of the code I wrote yesterday with routes, but I made it a little bit more robust. So the first thing I want to do is talk about the actual database logic that I've added. I am using a library called typeworm. Typeworm is for TypeScript object relational mapping. So what that does is it allows us to treat those statements like select this from here, etc. It allows us to treat these databases as classes. Classes are easy to deal with. We do that every day. So we're not writing that garbage SQL. We are literally just manipulating a class and its objects. Typeworm is a heavily used library. It's used in production everywhere from solo dev projects all the way up to Google. So I would recommend using it or something like it. There's a bunch, but it's my personal favorite, which is why it's the one I'll be talking about. The first thing we do is we need to set up our actual database entities. Now, an entity here is just going to be our class. What I will be doing with this database, it's very simple. I have users and I have notifications. And one user can have many notifications, and that's it. We're keeping it as simple as possible. So let's look at our user class entity here. So I don't know how to do this off the top of my head immediately. I mentioned this yesterday. I look at Typeworm's documentation, and they'll say, oh, you want to make an entity? Copy and paste this code in and change it depending to what your needs are. So base entity is just some logic that they have. These decorators just do a little bit of magic that allows us to, again, have Typeworm recognize this as something that Typeworm should be looking at. So in this database, we have a user. And now if we read this as a class, these decorators, again, are just simple notations for Typeworm to pay attention to it and treat it in a certain way. But we have export class user. A user has an ID. Now you can see that ID is mandatory. I put an exclamation point next to it. That's just a number. We have a username, mandatory. That's a string. Email's mandatory. All of this is mandatory. If you have an optional field, you would just do a question mark. It's an advantage of TypeScript. Now let's talk about these decorators real quick. This is something not native to TypeScript. This is something that Typeworm is doing. A primary generated column means that in our database, there has to be some unique identifier. Here, it's going to be our ID. Every time we create a new user, it's just going to increment this. So the first user we make will be user 1, 2, so on and so forth. And columns in our database, if you imagine this as an Excel spreadsheet, with the Excel spreadsheet just taking up a big table. So our leftmost column here would be user number 1, 2, 3. The next column, which I've set to be unique, is username, Steve, Tom, Alicia, etc. And it's just like an Excel spreadsheet. I think the table is a really good name for it. People have used Excel as a shitty database. It's sort of the same exact thing. Before I get super deep into this, do you have any questions right now?
So what is everything stored as?
Where is this being stored?
Like what kind of, what's the data? What exactly is?
So what's the data and where am I storing it?
Like what's the format? Is like a CSV file?
So the data right now, in the actual Postgres table, or in our database, what that is something called a B tree, which is a data structure which is going to hold indexes for where our data is in certain places. In this instance, when I show you the controllers that we've written, what we do is basically we're storing objects. This is an abstraction. It's more complicated. If you take the database class, they go really in depth. But essentially what we're doing is we're storing objects. And this B tree structure of this database allows us to retrieve and edit these objects very, very quickly. So here, you can conceptualize this as we have, imagine you have a vector of users, right? And I say I want to look up a user by their ID. Now, a slow way to do it would be to pass through this vector and at each index check, is this the right ID? Is that the right ID? Etc. Until we find the user we're looking for. Our database is just a more efficient way of scanning a vector. It's not stored in a vector, it's stored in a different data structure, but essentially we're just going through this data structure to find the user that we're looking for. And then once we're there, we can do our CRUD operations. Are you in data structures right now? Have you taken it yet?
I think
Yeah, you'll talk about B trees, and then if you take the databases class, you get like really into it. But databases are built to be wildly efficient. But even so, there's milliseconds that count. You know, when you're dealing at scale of like millions of operations per second, and there are ways that you can speed it up. We're not going to have too much time to talk about them today, but it's about writing efficient queries, lets you find and edit things quickly. Alternatively, if you want to cache information, like, oh, it turns out I get this user every single day, why not just store that in memory or in a place closer to memory so I don't have to traverse this tree structure every single time to find this user. There's tricks. So if we keep checking out this user, we'll see at the very end, and we see this create date column, update date column. That's just Typeworm automatically creating a date for us. So before it was the ugly SQL language of like create date timestamp at in all caps. This is just a little more user friendly and it's doing the exact same thing. What it actually does is Typeworm reads this file and just creates the SQL for us, which is pretty handy. And then if we look at our notifications, now this is a one-to-many. And this syntax is pretty important. I would recommend if you have to do one-to-manys, please just look at their documentation, copy and paste what they have, and change the names of the variables. Because if this doesn't match exactly what's on the notification side, it's going to give an error. And if we look at the notification, so notification should be many to one. So this is the same exact looking thing. This is just a class. Notification has ID, text, thread, etc. We have a notification here, and in this decorator, I don't want to focus too hard on the syntax. We have a function that returns a user. When we pass in a user, we get their notifications. And that has to match on the flip side. This. And my screen isn't quite big enough to show them side by side while being this zoomed in, but we'll see. User gets user notifications. So over here, we need notifications as notifications.owner. The owner is the name of this variable over here. And on the left side, we get user.notifications. So notifications must be the name of the variable that we're trying to get over here, and it is. So those have to match. That's what I was referring to. Cool. So if we want to start actually doing things with this database, we now have our users, we have our notifications. How do we actually make a user? So over here, we have to look at our controllers. Now, our controllers are a part of Express that's going to control how we actually do our business logic when we access our routes. Let me close these guys real quick. So let's just get all users. I think that's probably the easiest one that we can make right now, aside from like a hello world. Hey, Anthony. We're doing databases.
I saw your message in the Slack.
So if we want to just get all our users. Now, I've already put 1 or 2 users into our database, so hopefully we should return something. Let's just make the function first before we even call it. So we want to get all users. There's a request and a response. And we don't need that request, so we do the underline or the underscore. And there is some Typeworm specific syntax here. I'm not here to teach the syntax. Again, I just look at their examples every time I have to do something. But const users equals await user.find. So user is going to be our user table here. And the .find method is just going to get us everything. You're not expected to memorize these. I don't have them memorized. So we're just going to console log the users. If there are no users, so we want to return a status of, hey, something went wrong. So that's a 404, or that sounds like a 404 to me. Otherwise, we give it 200, everything's A-OK, and we do a JSON for our users. Return a JSON of our users. So how do we actually call this function? Let's take a look at our routes here. So for our routes, I wrote some routes. They're going to look a little bit different today. This is just a little bit of a better practice way to write them than by just typing everything in index. So you'll see here, I have const router equals express.router. Basically, I can add them all to this router, and then I can export the router. And if I'm doing all of them in here, it's a lot more readable and maintainable. So for example, if I go to just the home route, so router.get / is just our home route for localhost 3000. That is our route. That's our function, get all users. So I think it's a little bit easier to read. Get all users is what we just wrote. So if we go to localhost 3000, let's see what we get. I would recommend using Firefox if you're doing anything like this. It's a lot more readable. It has this native stuff to it. Cool. So I got a couple things here. That's user 0. Everything looks okay. More on the password later. We can see it's got all the necessary information. It's got a couple notifications. Looks like there's another user, Colin 2. So that's all our users. Great. Where are we at? How are we doing? Cool. So how is this actually hooked up to the database? Because we have a route here. We have functions in our database, but how is my actual database on my machine storing this and able to get it? How does that interact with Express? Well, let's take a look at two things. This is going to be right in the Typeform docs, and any other library that you'll use that's like Typeform will have something similar. You have to export a data source. That's just what they call it. So there's a bunch of fields here. If we were using MySQL, we would put MySQL here. If we were using, SQLite, doesn't matter. Host, so 127.0.0.1 is your local host's IP address. If you're running this locally, this should always be the IP address. If you're on a cloud somewhere, you're going to want to make it whatever your IP address is. If it's going to a different point in the cloud. If it's on the same machine that you're on in the cloud, well, that would be your local host at that point, if you're all running it on the same point. So you would leave it alone. Now, I happen to know that Postgres always runs on this port, 5432. It's easy to remember. So when I created a DB with my pSQL shell, I called it testDB. So you can call them whatever. Doesn't matter. Username and password, I would recommend keeping them as Postgres, like I said. These other three aren't important for now. Synchronize just means every time you fire up your database again, make sure you're synchronizing with what's previously on there. This line is important. What entities are going to be stored in this database? Well, I want to keep my users and I want to keep my notifications. Those are the two entities that this database should be considering. And if I want to make my application more complicated and I want to add, classes, let me use a different word, and I want to add jobs, well, I would have to add that to this array. So I'll take a look at index.ts. The very first thing I do in index.ts when I have an application like this that's using a database, data source.initialize. Simple enough. This fires up everything that's happening behind the scenes for this Express app to get connected to our actual database. So you just see, simple enough, console.log initialize successfully. If not, it's going to be bad. And what we can see here, let me show you this. So I'm going to shut down the database real quick. I just turned our Express server off so the database is not connected. If I start this database, that just spit out a whole lot of stuff. A lot of stuff. So immediately, this is the SQL that it's generating for us. It's console logging the SQL that it makes from our statements. So we could have written all this, or we can type data source.initialize. This is why I'm teaching you Typeform, not actually writing SQL. I would recommend becoming familiar with SQL, especially select, join, where. There's some important keywords, but just to get you going, let's start with Typeform. So once we have everything connected and we're able to access our database, we can do more things than just creating a user. That's pretty simple. What if I actually forget what functions I wrote for this, so it's going to be a surprise. Delete user. Do not want to do that one yet. create user, right? So this is a login function. So hypothetically how this would work, if we have a React app that's on the front end and we have our Express on the back end that's connected to our database, we would make a fetch request from React that's going to contain or going to be classified as a post request. It's going to contain all of the body information that's necessary, probably the username and password and second password. And then it's going to submit that to this endpoint. Once this endpoint gets it, so that endpoint would be at, for create user, that would be at, well, let's check our routes. Looks like it's just a post request to our source endpoint or our home endpoint. So we should be able to do that. Sorry, where was I? Users. So when we create a user, we talked a little bit about the request before. Every time we make a request to an endpoint, the request contains some information. Now, the request contains, it can contain parameters, which we don't have here. It can also contain a body. Now, the body of a request is going to have basically key value pairs, where we can say password 1, password 2, password, and whatever information we want. So we go to the request, we get the body, and here I'm asserting that username, password, and email exist in this body of this request. If I were making this a real website that I wanted people to use, I would do some error checking to make sure that it's actually getting those, and if it doesn't get those, handle the error gracefully. Because right now, if I submit something without these, my server's going to crash. So hoping for no typos. This is something worth mentioning, hashing passwords. I've alluded to it before. I always use Bootcamp.js if I'm on JavaScript. You don't need to know how this works. You can take like network security or cryptography class if you want to know. But we don't want to ever transmit our text or our passwords over plain text. If someone is listening, they get the password. This is a disaster. I know someone who got fired because they forgot to use Bootcamp.js for something and they got shown the door like 3 days later. You got to remember, basically what it does, we hash the password to encrypt it, and then if we're checking to see if someone's logged in, we just hash what they give us, and if the hashes match, they're good to go. We never store plain text passwords, ever. I can't say enough how bad that is. Half the time when you get an email that's like your password has been compromised or found in a breach or whatever, it's because somebody fucked up, stored it as plain text. Guarantee that person gets fired. It's really bad to do. So here's what we have going on over here. I just have a try-catch block. All of this, this is type-worm stuff. I checked their documentation, copied and pasted it, but what we're doing here is we're getting the data source. We're trying to insert something into the user table, which means adding a user. The values that we're including, well, I think when we define user, we said it must have a username, it must have a password, and it must have an email. So we're saying username is going to be the username we got from the request body. Same with password. Password is the hashed password, which is we initially got that from the password. And email's email. So we'll be storing the hashed password. We're going to execute this. Then here's a line here that probably wasn't in their documentation. But I wanted to return this user once I got it so that I could start working with it. And when I console logged what I got, it wasn't just a user. It was some raw data, which was an array. And the 0th element of that array was the user. So this is just like if you play around with it, if you just log what's going on with this user and see, oh, nope, it's an array, grab the first index. There will be some fiddling with that. But again, having written raw SQL, I would take fiddling with something like that 10 times out of 10 over having to actually write SQL myself. I've come down really hard against SQL and front end in the past 2 days, but I stand by everything I said. Leo's giving me a thumbs down. If you want to hyper optimize your queries, especially for super high throughput operations, you really should be writing raw SQL But for something like put a user in a database, you can probably get away with something like this. Again, we're talking about the difference between something for a Hoya devs project versus, oh, I work at Facebook, and if I don't shave 3 milliseconds off of this query, Mark Zuckerberg is going to shoot my family. Like, that's when you would use SQL. He would too. Dude's definitely got assassins on the payroll. So let's take a look at creating a user, okay? Now, I have these curl requests that I have copied and pasted because I didn't want to mess up typing them because they're hard to type. Typically, when we want to test something like this and it's just, oh, make a GET request to the endpoint, that's simple. As soon as we're doing posts that, or post requests or delete requests or anything that involves a lot of data with it, because right here we have to send the username, the email, the password, all this stuff. This is a lot to curl and it's easy to mistype. There's something called Postman that I would recommend you check out. You can download a client version. You can also just access it in a web browser. What this does is it just allows us to make, can I make this bigger? I can't make it big. Oh, I can. Postman allows us to make requests. So like if we query the users right now, if we just do a GET request, this is the same thing that our browser showed us. But it might be easier if we wanted to do, for example, a post request. We can put in the same thing. So here it would be users. And then we would just do include any headers that we need, include any parameters that we need if we're doing a query, etc. Do you have a question, Leo, or are you scratching your glasses?
No, I'm going to say something once you're done.
Got it.
I'm gonna plug them
I only super use Postman if you're doing anything with authentication that requires a token or a cookie, because that gets really hard to do with curl, not so hard to do with Postman. You just put it in. What's up, Leo?
I would like to push a Thunder client. It's a VS Code extension that is Postman built into your VS Code.
Sorry, what's this called? Thunder client?
Yeah,
Okay.
it's really good. I've been using it while I've been developing our Express stuff for devs.
That's awesome because I don't like using Postman that much unless I have to.
Yeah.
Thunder client is in VS Code.
Yes, and it's like literally the same functionality.
That's why he's here.
No other reasons.
Well, no, it's because I know all the old boomer stuff, and you're like, this is the newest thing, and it's the best, and you got to know about it. Yeah, right? So let's make a user. So I'm going to just curl here. Disaster. So we're seeing curl post. Here I include a -h. You just need to basically format that you're sending it a JSON, or specify that you're sending it a JSON, and then D is just going to be our data. So we have single quote at the beginning and end, double quotes for everything else, username, email, password. Now, if I send this to this address, I should, if this is correct, I should get a duplicate user found error, or this user already exists error. Because if we look down, you'll see if I catch an error, return error, user already exists. I just grabbed this error code from the stack trace when it bombed out. Let's see what it gives me. User already exists, cool. And if I check over here, duplicate key value violates, et cetera, et cetera, et cetera. So this is the actual error. It's going to say 235 or 23505 somewhere. It's not important. But it's just a little trick you can do is like check error code. You can also just handle the error yourself and do the manual checking. But if I want to make a new user, now we can have duplicate passwords. I think we said that username and email had to be distinct. Sick. So we just created a new user in our database that's on my machine. So by interacting with our actual web application, there's now something on the database. So if I do a GET request now, just to our endpoint that we have set up, I should now see the user Kalina. Absolutely love to see it. Something that's always really satisfying for me is seeing the SQL spitting out the actual correct stuff and there's no error messages. It's It's that all about that dopamine hit. So again, we have sort of more of the same here. If we look at create notifications, this is the same thing. We're doing a post request. The H for we're sending it a JSON, D for what the actual data is, notification, second notification, test, etc. And the same thing, we're going to that endpoint. So when we create a notification, this time we're using the params and the body. Now the params, if you remember from yesterday, we need to create a notification specifically for a user. Now there are two ways that I could think about doing this. You could just post request to the main route and include the username that you want to send it to in the body, or you can make a post request using these query parameters. So right now, we wouldn't send this to localhost 2000/users. We would send it to localhost 2000/users/username that we want to send the notification to. So here we would let's send a notification to Kalina. So that's going to be the request.params.username. That's what we're saying that is. And then notification message is just going to be what's in the actual notification. Now, there's a little bit of typeform logic here, but we're saying make a new user, or not make a new user, declare a new user variable. Now it can either be a user or it can be null, because there might not be one, but we're trying to go to the user repository is basically all of our users. It's our data source.get repository for users. So it's just looking at all our users is how you can think of it. Go there, find one. So find one is going to be, before we saw find was find all of the users. We need to find one where. So find one takes an object. The object has a field called where, which takes another object. And we're saying this is where we can specify what we're looking for. Find one where the username is the username. Or we could do find one where the date creation was on this date or something like that. But we have control over what we're finding. And this is really the advantage of using a database over let's just store everything in a vector. This would take years. The databases can handle it really, really quickly. So basically I'm saying let the user equal this user. If it doesn't come back, so if it comes back null, return a status saying user not found. If we try to make a notification for a user that doesn't exist. Now if it does, let's just take everything from the body of this request, text, .read is a Boolean if the notification's been read or not. So we're just saying that that's false because we're making a new one, everything, so on and so forth. Creator ID is the user ID because every single notification is created by a user when they get the creator ID. That's just how I define my schema. That's what made sense for my business logic for this. Maybe the creator ID is some administrator who sends a notification to something, and then we need an administrator table. But that's how we can do it. And then we just notification repository, save this notification. So now we're just saving it in this basically notification holder. You can think of it as just a bucket that holds all the notifications. And then we return a status saying, yeah, this was created okay is what 201 is. And .send, well, we're also returning the actual notification itself. Let's create one. I struggled with this today because I didn't have a closing parentheses. So I guess I should be using Thunder Client. What was it? Thunder Client. Thunder Client would have solved all of those issues. So I want to submit this to Colleen is the user I want to make it for because that'll take the request parameters. We'll call it second notification. Great. Cool. When I get text like that, I'm always happy. So if we look to Colleen, there she is, and we have second notification. So we just made a notification. So again, I hope you're starting to see how we can connect React. Well, we've used fetch requests before. We use a fetch request to hit this endpoint. Once it hits this endpoint, we do our database logic and our controllers. We're good. That's full stack development. We've got into it. We know how to do HTML. We know how to do React. We know how to do Express servers, and now we know how to do databases. Now there are a couple others. I don't think I have an update example here, but I should have a delete. Let's see if there's a delete. Yeah. So let's delete this user that I just made. So again, let's just look at this logic for this function. User ID is going to be the request.parameters.userid. Cool. That's not too bad. So again, we're going to the specific endpoint. So this would be /user/:a would be how we get to that, how we get those params. Const user is a user of array. So we're awaiting a user.find where ID equals user ID. Now there should only ever be one of these because we've disallowed people to have matching usernames. This was just to be safe. It can't hurt to do this unless we're really trying to micro-optimize. But if user length is equal to 0, well, that's the same thing as if user is null, right? Throw, say this user doesn't exist. Otherwise, let's delete them where, so this is an object, the ID of the user. So if we go back to our user table, great, equals the user ID. And then we send a status saying that, yeah, we got this done. And then user 0 would be our first user and only user in that array. So let's try to check this out. This is the last example we're going to do before I want to talk about some middleware. So we wanted to delete user number. Let's see what we got. The colon A is user number 7. Let's get rid of it. Nope. What did I do? User equals rec.params.user ID. Let me check the actual route that I have set up. So the routes would be user. So we're calling delete user when we go to the endpoint of user ID. So what we should be doing is going to this endpoint, right? That's user/7 is the one we want to delete. And then in the actual logic, we have user ID is just, yeah, we turn it into a number. We get the user ID. That looks good. Let me try. This is a classic example of this was working before class, and then I changed something, and now it is no longer working. I don't think we actually need. Nope, wasn't that. Oh, I think I know what I did. Okay, this happens all the time, and I should have thought of it earlier. When we tried initially to delete this, I did not specify a parameter. So I said, because I didn't specify anything, oh, you'll see this error all the time, violates foreign key constraint. Because I didn't specify anything, it tried to look for a user that didn't exist. Because I didn't handle this error gracefully, killed my server. So let me start it up again. Just going to Control C. Hopefully this will do it. I think it's just users. Botched it. Okay, so I'm actually going to explain. I'm actually now glad that I got this error because I've seen this error a million times and it's always not great to deal with. So I want to talk about cascading and what that means in terms of deleting something. So I'm seeing here this error. When you see foreign, there's two triggers for you to see this, and this is like the most common one. Violates foreign key constraint for an update or a delete on a table. And then you'll see key is still referenced from table notification. So let's take a look at the relationships between these two schemas. If we look at user must have notifications. If we look at notifications, even if the array is empty, it'll still have an array, it'll just have nothing in it. If we look at notifications, all it has with user is that it has a many-to-one relationship to user. So if we attempt to delete a user and don't do anything to their notifications and don't specify that we're handling this in any specific way, what's going to happen is we delete a user, notification still exists. We have said in notifications that a notification must have a user. It now doesn't have a user. Our database is now corrupted. Postgres and most databases will handle this by just saying, hey, you messed up. Don't do that, please. Here's an error. And in this case, it crashes our Express server. So we need to cascade. Now what cascading is it says basically at the most simple level, if I delete a user, delete all of its associated notifications first, and then delete the user. And you can cascade all the way down. If a notification then has another thing that it's one-to-many with, like a notification has a field, well, delete all the fields first, then delete all the notifications, then delete the user. Let me see if I did that. Oh, I do have onDelete cascade here. So cascading should be true. OnDelete means that I should be cascading. OnUpdate means I should be cascading. Eager means that when I update it, I'm updating it both sides. Allow me to rephrase. I'm actually going to read what this says. Okay. In Typeform, it just means that when you load up a user, it will automatically load the notifications as well, preemptively. So I'm sorry, that's not what I thought it was. I'm going to try one more time here, and then I want to talk about middleware for 5 minutes. Leo, how often have you run into cascade issues or like foreign key issues in Postgres? I don't know if you've worked with Postgres super heavily.
I don't use Postgres that much.
Postgres is my go-to. A little bit embarrassing that I'm botching it. Okay. I don't think I actually need to pass it data. Nope. Okay. If I scroll up, I think. I'm not going to think too hard about it. So what should happen is we delete it and we get the user back that we deleted. As far as the controllers go, these are some basic ones, but I tried to include different techniques for querying the database or for updating a database or deleting. If you reference this code and more specifically the Typeform documentation, you should be able to write these guys pretty fast. And typically the way we organize this is I only have one controllers here. If I had one that was specifically altering notifications, I would have notifications.ts. So typically you try to make like an associated, and this is just a best practices thing. If I do user, I should have user.ts capital should be the entity, lowercase should be the controllers or resolvers that involve users. Keeps it simple. The last thing that I really wanted to talk about, did you have any questions real quick? I know that was like databases in 3 seconds, but cool, we're gonna move on. Sorry, were you gonna say something? It looked like there was a thought. Okay. So I talked about middleware yesterday. I talked about specifically logging middleware. So here's an example of how it would be. Just a really, really basic writing to console. Typically what you would do is you would write to a database, or at the very least you would write to a text file. But I'm just console logging this. So here's where this runs. We see request, response, and next. Next function is a really, really important part of Express. What it means is when you get a request, do all this stuff, then go to the next. Next could be next function in your middleware that you have, or alternatively, in this case, it just means get to creating the response and get it back to the request or the client. So this is pretty simple. rec.body.request time equals date.now. So we're just saying the request time for this is going to be now. We're also logging the URL that we get this from, any parameters that they search for, any query that they search for, the body of their request. This is pretty standard stuff. There's libraries that will handle this for you, but The main middleware that I would say is important, which is what we chose not to talk about today, was authentication, which I mentioned a little bit yesterday. It's really, really important that you protect parts of your app from places where users should not be. If you aren't logged in, you should not be able to see your emails. That's ripe to all sorts of security abuses. If you are, I don't know, logged in as a guest, there's other things that you shouldn't be able to do. How do we handle this on the back end? Well, on the front end, people can edit things in their browser. They can spoof things. It's not really possible to have really great security if you're only doing it on the front end. What we typically do on the back end is write an auth function. Now, there's a million different ways that we can check if a user is authenticated or not. Most of them will revolve around some form of, does this user have some token we've issued them? Now, that could be a cookie. It could be a JSON web token. It could be, I don't want to talk about OAuth too, but basically that's just another form of a token. What we would do is every single time that a request is made, we have some middleware function that's just like is authenticated. Now we could check, is this session active? Now a session is just exactly what it sounds like, a session of communication between a web browser of a client and your host. Is the session still activated from before when they were authenticated? If so, send it on. Does this user have the token? Send it on. And so on and so forth. Otherwise, shut this all down immediately. Don't let them see anything else. Don't allow them to access any other routes that should be behind protected routes. And what we do is, when we create these routes, we just specify which ones are protected by this middleware and which ones aren't. So let me see the routes one more time. I did not protect any of these with authentication middleware because I didn't write this for this example. Authentication is, in my opinion, the hardest thing that you are going to do in terms of just developing an app. There's a lot of mathematics that goes on if you want to understand how it actually works. You'll have to deal with cookies. You may be caching the cookies in your browser, which speeds up authentication so that users don't have to wait quite as long. You may be using a key value data store like Redis, which is another database. It's pretty common to cache credentials in that. JSON web tokens, you may store in local storage, for example, and their logic is pretty complicated. But ultimately, whatever we do, we're going to be using middleware to check before we allow a user to access an endpoint. I'm going to call it there. I think we got a couple minutes left. Any questions on either end? This is a lot of heavy stuff that we moved through pretty quickly. Cool. I'm going to post this repo. This is the repo named called Express Test on my GitHub. If you go to the Software Engineering Bootcamp, at the very top of the slide on databases, I've linked that repo. If you want to get this code, I think it's probably going to be pretty helpful. So hope everybody who sees this is having a great break. Take care, guys.